Hi guys, so this is 4.4, just a little bit of a heads up for chapter 4. I had originally thought that I wanted to do a quiz this week and then a test after the end of it, but looking ahead, I remember I made myself a note last year when I was teaching this. This is a really hard and kind of heavy chapter, so instead of taking a quiz this week, what I want us to do is finish up 4.4. And for the end of 4.4 in itself kind of is like the end of a massive big chapter. And then the next three or four sections of chapter 4 are kind of like a whole other chapter in themselves. So I'm actually going to break chapter 4 up into two different tests. So we're going to take a test 1 and then a test 2. I'm not going to put any quizzes in this section, just two big tests because this is a lot, like this is one of the most important chapters of precalc. There's a lot of really important stuff going on in it. So I want to make sure that I give you the opportunity to show me what you know, and then we can take some time after that first chapter, the first test of this chapter, to go over anything else that we need to, so you can take a retake, and then move on to the second half of it. So really, this should be broken out into two separate chapters. And I remember telling myself last year that I wish I would have done this. So I'm going to go ahead and do that for you guys this year. So after 4.4, we're actually going to go ahead and take a test, and then move on to the rest of chapter 4 and take another test. So anyways, chapter 4, section 4. So thinking back, I gave you a big chart that had how to find your sine value, your cosine, your tangent, and so on. So in section 4, we amp this up to say that it's not only just acute angles, or just finding the actual cosine, sine, coordinate, that's what I was looking for, coordinate point on the unit circle. We want to find line segments, and there, for those angles, that's not just on our unit circle. How are we able to find the 6 different trig functions of those kinds of angles? So this would be if I just had an actual line segment coming off of my xy coordinate plane, and I have it going out to the point xy. So how could I possibly find all 6 trig functions of this angle? In order to do that, we know, again, we have our xy coordinate point out here. We come out and we come out to a coordinate point. But now we're introducing this r. R is representing the length between the axis and this xy coordinate point. So it's essentially creating another triangle. To find r, you use the square root of x squared plus y squared. So it's essentially creating a right triangle in that we go over x and up y, and the hypotenuse is our r value. So this is the original like little chart that I gave you to just find something coming off of the unit circle. So once we add in our values, now any place that there would have been a 1, so like y over 1, x over 1, 1 over y, 1 over x, that 1 is now replaced with an r. So it's y over r, x over r, r over y, and r over x. So just to show you the relationship between our new kind of chart for finding these and what the old one looked like. Okay, but again, to find your r, you will have to use the square root of x squared plus y squared. All right. So let's go ahead and do an example. And unfortunately, I think we're going to have to erase all of this in order to do that example. So given the following diagram, that's not exactly what I wanted. Nope. This point is -3, 4. No, you can't say that at all. Let me bring this down a little bit. I apologize, my dot cam is broken, so I have to do this back up on a board again, not on a sheet of paper. Okay, Okay, negative 3, 4 is that point, negative 3, 4. We are trying to find the angle theta. So I want to use this diagram to evaluate for sine, cosine, and tangent. So I first have to say, well, what does this mean? This is saying that my x then equals negative 3 and my y equals 4. Because it's the coordinate point, negative 3, 4, x equals negative 3, and of course that's in the middle of the glare, so you can't see it. X equals negative 3, y equals positive 4. So I have to find my r value in order to complete the rest of this. So r equals the square root of x squared plus y squared. So negative 3 squared plus 4 squared. So r equals the square root. Negative 3 squared is 9. 4 squared is 16. So r equals the square root of 25, meaning r equals 5. X equals negative 3, y equals 4, r equals 5. Okay, so now I have to just basically fill in what I know with that kind of chart that I gave you before. So again, sine equaled y over r. Cosine equaled x over r. And tangent equaled y over x. So filling in the values that I know, I can say y over r would be 4 over 5. And that would be my sine value. X over r, x is negative 3, r is 5. So that negative adding in would be a negative 3/5. Tangent is just y over x. So 4 over negative 3, negative 4/3. Okay, and those are those 3 different values then. Okay, so moving on to something kind of just a tiny bit harder, kind of standing off of this. So we've talked before about where in which diagrams x and y are positive and negative, along with then when are cosine and sine positive and negative. So I'm going to give you another chart that kind of is just like that. So when we're counting out our quadrants, we always count 1, 2, 3, 4, right? So 1, 2, 3, and 4. You count counterclockwise. So I'm going to fill in sine, cosine, and tangent. And after that one, I'm not going to actually say sine, cosine, tangent. I will say S, C, T. Sine, cosine, tangent. Sine, cosine, and tangent. So there's a saying that goes along with this, and it's referring to what kind of trig function is positive in which coordinates. So the saying is all students take calculus. So again, what the saying is referring to is which of those trig functions are positive. So all is quadrant 1. All students take calculus. So all would mean all 3 of these trig functions are positive. So then students, only sine is positive, the other 2 are negative. Take is t, right? So tangent is positive, the other 2 are negative. Okay, and then calculus is c, so cosine is positive, the other 2 are negative. Again, the saying is all students take calculus. Super untrue saying, but a fun way to try to remember that. So these are not referring to the coordinate points. These are referring to the actual trig functions themselves. So when we are evaluating for trig functions that are not on our unit circle, again, what we've just been doing before. So in this case, sine equals -2/3. That is not a coordinate point on our unit circle. So we know that we are off of the unit circle. I can't use any of those methods in order to solve for this. This marker is running out just a little bit. So sine again is -2/3. And tangent of theta is greater than 0. Okay, that's going to be a really important piece for us. I want you to find cosine and tangent. So again, knowing that sine is -2/3 and tangent is greater than 0. We want you to find cosine and find tangent. So 2 things here. First, we need to figure out what quadrant does theta lie in. Theta could lie in quadrant 1, 2, 3, or 4. So very first off, let's try determining is sine positive or negative. So right away we're knowing that sine is a -2/3. So that is already crossing out quadrant 1. I know I'm not going to be in quadrant 1 because quadrant 1 has a positive sign. Sine is obviously not positive, so it can't be quadrant 1. Sine is also positive in quadrant 2, so we cannot have a theta in quadrant 2. The last 2 quadrants I could be in is 3 and 4, because sine is negative in both of those quadrants. The last piece of information says that tangent is greater than 0. If it's greater than 0, that means that it's not a negative number, right? It's not a -1 or -2, -3. We're greater than 0, meaning that tangent has to be positive. So tangent is positive in quadrant 1, but we've already said quadrant 1 is out. Tangent is also positive in quadrant 3. Sine is negative, sine needed to be negative, tangent positive, tangent needs to be positive. So this is the one, right? We are lying in quadrant 3. What does that mean for us though? This means a couple of different things. It will help me to determine whether or not in the end cosine should be negative or whether or not tangent should be negative or positive, okay? So knowing I'm in quadrant 3, I can go ahead and try to figure out what is my y value, my r value, and my x value. And then eventually, what is my cosine and what is my tangent? So pulling this sine value apart, we know that if I'm not referring to a value on the unit circle, that sine is going to equal y over r. So obviously my negative is going to be coming from the -2 because my r value is not going to be a negative value. So if I'm trying to figure out my y and my r, my y value itself is a -2. Again, also sine is negative, so coming from this -2. My r value then would be 3. Again, we're taking this fraction. The top value tells me my y, the bottom value tells me my r. Okay, so my y is going to be the negative. And again, y values in this quadrant are negative, so it makes sense that y is my -2. So now I need to find my x value in order to find cosine and tangent. So the way that we find an r value is by taking the square root of x squared plus y squared. Okay, so think about how we could instead put this in terms of x. So if you do a little bit of manipulating here, you would have to square both sides to get r squared equals x squared plus y squared. Again, I'm trying to isolate my x So I'd be subtracting over a y squared. So r squared minus y squared equals x squared. Again, I just squared both sides, and then I'm trying to isolate my x. I'm trying to put this in terms of x. So subtracting over y squared. Last step would be taking the square root to get rid of this square. So x equals the square root of r squared minus y squared. This will help me in determining my x value up here. So x equals the square root of r squared, which is 3, minus -2 squared, that's my y, giving me 9 minus, I don't know why I put that in parentheses, -2 squared is 4. So x, let's see this, yep, you can see that x equals the square root of 5. Okay, so here's the part that many people forget. My x values in quadrant 3 are actually negative. So knowing this, when I'm taking the square root, you always take that plus or minus symbol, correct? So I'm determining that because x is in quadrant 3 and x values are negative in quadrant 3. Again, we just know this because if I'm going on this side of my axis, these are negative x values. So you are truly just going to take the negative version of the square root of 5. So x equals negative square root 5. Since I now have all 3 of my terms, I can continue on by finding my cosine and tangent. Cosine is, we get cosine by taking x over r. And we get tangent by taking y over x. So for both interest, I need to leave myself some more room for that one. Let's do this one first. So cosine equals x over r. X is negative root 5. And r is 3. Since that radical is in my numerator, I can leave it like that. But tangent equals y over x. So y is -2, my x is negative root 5. First thing I see is my negative cancels out with my negative. So I'm getting 2 over root 5. However, I need to rationalize my denominator, meaning multiply by a funny looking 1 that gets rid of this root 5. That's root 5 over root 5. 2 times root 5 would be 2 root 5. Root 5 times root 5 gives me just a 5. So my cosine equals negative root 5 over 3, and my tangent value equals 2 root 5 over 5. And again, you can go ahead and find, I did say tangent. Okay, I was just checking. So you can go ahead and find the actual numerical value of these if you want to plug that in your calculator and plug that in your calculator. I'm fine with you leaving it just as this value though. I think that's all I need. Yeah, I think that's a good enough example for us for this chapter. So yeah, I'm happy with that. I'm just checking this last example to see if it's one that is anything different than this example. Nope, we're good. Okay. So again, understand that chapter 4 is really hard. Like I 100% understand that. I know this is a really tough chapter. This is like the chapter where like the poop hits the fan kind of thing. It's not easy. It's really difficult. This is a whole new kind of math that we're kind of bringing in. So up until this point, we've done a lot of Algebra 2 review. Now in Chapter 4, you are really getting hit with precalc. Like this is just like hitting a brick wall of like some of the toughest things in precalc. People a lot of times do struggle with trig. It's just tough. A lot of this can kind of look like a foreign language because we're using a lot of different trig functions, and it's not just numbers anymore. And there's a lot of moving parts to each and every example. So if you're having trouble, especially remote learners, please don't hesitate to reach out to me. I understand this is difficult, and I want to make sure that you do understand and that you're not having difficulties with this at home, and that we can work out kind of any confusion that you're going through. So don't be afraid to understand that this is going to be confusing and to come to that kind of consensus that you need to reach out for help. I'm available to you at any time if you need even more, just more examples. I can also create some more videos and send those to you. So please just let me know. Be trying the homework as much as you possibly can. It's going to be really confusing without that. And since we're going to be having a part 1 test coming up here soon, I really want to make sure that we're all kind of prepared for that. So please let me know if you need any help. Otherwise, have a good day.